All right, sorry for starting up again slow. We're making term 2, lesson 5, the programming exercise from adhesive.com. The URL for adhesive.com is up here. So far we've talked about what we need. We need a driver class, and that is the student runner student, which we downloaded from Adhesive. And it tests the student class using the student class constructors and using the toString method, which is used when we send the student class to print line. We'll come back and talk about the driver class shortly. But right now we're going to follow along with the student class. We find out what we need to have in the student class. It's listed over here on the left or the right side. Your student class should include the following. We walked through this. So this will list all the variables that we need to include in the student class. So the variables are here, and another first name, last name, grade level, GPA, and a student ID, and the variables that are input into a constructor down here. We see what kind they are. All right, so we see first name and last name are strings. So in the student class, I need a first name and a last name, which are strings. And we have default values. If there's nothing there, first name should be none. And last name should also be none. And I'm scroll off the screen. I'm going to try to keep all my text in the same area. And this should create the first name and last name. Excuse me. What is that thing? Java has this control I, which is correct indentation, or sorry, Eclipse, and this will make everything pretty for you. So if you click on Control I, when you're in, it will tab everything over depending on where it is in the scope of your classes. So here I have 2 class names. Now these strings should be private. And private means the only way to access these strings is through the constructors, getters, and setters of the class. So now we have 2 of the 4 variables that we need in the class, the attributes, and so we need the other ones. Can someone tell me what is grade level?
Dr. Shi, were we not supposed to copy a file from the thing and put it in like I thought you said you did?
You mean like this one?
Yeah, that one?
This one is downloaded from, excuse me, Java. It's for testing. You will not be uploading this to Adhesive. You will be uploading your student.java to Adhesive.
So we don't put that in this one.
You need this to test your student run file before you throw it in Adhesive. If you want, you could type your student.java file, the object itself, directly into Adhesive, but it's harder to fix it in Adhesive than it is to fix it in Eclipse. And so what I do is I fix it first in Eclipse and then move it to Adhesive. So Adhesive has a test program that will run your student file and see if it works properly, but it won't tell you where it's breaking. And to find out where it's breaking, you can have it in Eclipse and see exactly what's going wrong. And so I highly recommend when you do these programming exercises, you do it first in Eclipse and then copy and paste the text into Adhesive. So we have the string. Can someone tell me, what do I write down for grade level? Private int grade level equals 0. Perfect. Thank you, Ajiro. Can someone tell me what to do for GPA? Matt.
GPA equals 0.06.
Okay, GPA equals 0.0, semicolon. Oh, it stalled. Why did it stall? There it goes. Yes, it should be private double. All right, so thank you, Matt. Thank you. Was that Stanford or Jiro? Stanford, very nice. So I'm trying to recognize you by your voices now. What's left? We have this ID. What do we do about the ID? ID? What's next? Int, right? These IDs are all ints. Now we do ID. Is it ID equals 0? All right, so we're going to come back to this one. I'm going to put some question marks here. Okay, so now we have what variables go into a student. Can someone tell me what constructors go into a student? So now on the methods. Okay, so we have this this method here, student, string first name, last name, grade level, GPA. So let's stick that in here. Student, string, and instead of first name, do FN. So name this something different than first name. If you don't believe me, we can do it on the second one. String, last name. And we have int, grade level. I'm going to go to grade level and double. And I'm going to use what is called reverse Polish notation. No, reverse Hungarian notation. There we go. I'm going to use an A underscore for GPA. I think this is called Hungarian notation. Now this method is a constructor. And a constructor's job is to initialize the variables in the class. So the user can pass the values they want using the parameters. In order for the user to use this constructor must be public. So now we see the signature of the parameterized student constructor. Public student, string FN, string last name, int GL, and double A underscore GPA. Now we're going to see why I use A underscore GPA shortly. We're going to see why I used FN instead of first name, GL instead of grade level, because when we try to assign last name, we're going to have a problem. So let's do this. The user gives us values. We dutifully stick the values into the names. So first name equals what the user gave us, FN. Last name equals what the user gave us, last name. Grade level equals what the user gave us, GL. And the last one, GPA, equals what the user gave us, A underscore GPA. There is a mistake, intentionally. Right here we have a mistake. Why is first name blue and FN brown in Eclipse? First name is a class attribute. It's a variable that belongs to the class. FN is a method parameter variable. So FN is defined right here. This is where we make FN, and it's brown because it's a parameter. It's a local variable to this student constructor. First name is like a semi-global variable. It's a class variable in the student class. And every method in the student class can see first name. Only this student constructor can see FN. What happens when I try to make a last name parameter variable? Now I have two last names. One's up here, and a different last name is here, but they're spelled the same. Which one do we want here? The blue one. Which one do we want here? The brown one. But we get the brown one both because this is the same name. So the easy way to get around this, I don't know which name to use problem, is to change the names of the parameters. The hard way, let's see if we can do this, is to use the student dot last name. Let's see if this works. No, it's mad at me. Why is it mad at me? This, okay, this. There we go. This is a keyword, which means the current object. A student class is a blueprint for a whole bunch of students. We can make every student, and each student can have their own first name, and their own last name, and their own grade level. All these students we make have to have a different first name variable to store all those different first names in. And they have to have a different grade level variable to store all those different grade levels. Each and every student in a method can be referred to by this. This refers to the current student. So when we create a student, the student that were just created is referred to by this. If you want them to have the same variable name, you have to say the blue one comes from this, and the brown one has no this on it. So this last name is the student classes, student constructors last name. Yes. Yes. And so this is one way to get around that. The names are different, but the easy way is to just name the parameters differently from the class variables. Now I have an ID. What does the ID do?
I think the one above is wrong.
The one above is wrong?
Plus a zero.
Oh, private static in
Yeah, it should be plus a zero.
It shouldn't be.
Should not be equal to 0?
No.
Okay.
Then
We're going to come back to this anyway. Then what do I do here?
ID plus plus.
ID++. Okay. Let's do the printer, because we need to test this now. I've made my student. It has stuff to store in the student, and it has a way to set the new variables. Now we need a way to print it. We need a toString thing. So it says, we're going to make this function here now, this method. ToString method returns the student information in this exact method here. The toString method is public because a driver is calling it. The toString method belongs to each individual student at a time, so it is not static. The toString method returns a string for print line to print. The toString method is called toString. This toString method has no parameters. Now we see a lot of print lines here. So in the first print line, we're going to, we need a string to return. Since the return type of toString is a string, we need a return string. I'm going to call mine retString. And it starts with nothing in it. And when I'm done with the toString method, I'm going to return the retString. All right. I'm going to save this file, and I see what happens over here. I have default constructors that aren't created, but now notice, whoopsie, let me go back, that this, it's red again. Why is it red? Constructor string int double is undefined. Actually, it is defined. Oh, the student class got touched somehow. Let me change that. Interesting. Well, something's mad. Oh, I got rid of everything in here. Let me do an undo. Where's my undo? There it is. Undo. There we go. If we look at our runner file and we look at the errors in the runner file, we now see that the error is saying that the student parameterized constructor is now complete. I need to complete the unparameterized constructor, the default constructors, before I can run my test file. Or, much better, I can just comment out this crap here. I'm doing control \\. That changes all these to comments. And now I have a runnable class. Right, I can run my test, I can run my student. Let's run this and see what happens. I need to move my pretty picture. In fact, let's just shut this thing off. I'm going to hide it. Where does it go? Over here. Terminated. It doesn't print anything. So let's see this toString and make it print something. In the toString, I must print last name, comma, space, first name. And so I'm going to pack that into my string. A return string gets concatenated with last name, concatenated with a comma space, concatenated with first string, first name. Now when we have this added, right, we just did this first line here, I need the end new line. And a new line. So I have last name, I have comma space, I have first name, and I have the new line. New line. And all these together gets the first name of the printer. Let's run this and see what the printer has. And save everything. Run it. And now we see Dovey show up. Let's show that again. Dovey, comma, misses, period. Dovey, comma, misses. I don't know why there's not a period here. So far, so good. Dovey, comma, misses, period. I have the first line. I don't have the GPA. I don't have the grade level. I don't have the ID properly. So let's add that to our printer. We need GPA colon and the GPA. So let's add that to the return string. Plus equals, it starts with GPA colon space, and to that we add the GPA. And to that we add the new line character. So that's the second line. Let's run that and see if we get what we need. Scroll up a little bit. All right, so far so good. The next thing is grade levels and the ID. So let's put that in our printer. Grade level, whoopsie, plus equals the name grade level colon space and the current grade level. Now I'm putting returns in mind so you can see all the code. You should be able to see more of the code when you type, so you don't have to make yours as ugly as mine. So that's part of it. Oh, I spelled grade level wrong. Look, it's mad at me. This needs to be a capital L. Okay, after the grade level, I need a space, ID, space, a pound sign, space. Space, ID, number, and to this we add the ID number, which is currently ID, and the new line. Notice I did not add a new line at the end of grade level because grade level and ID go on the same line. Now if we have everything, it should look like this. Let's run it and see what happens. So it looks pretty good. Except I didn't use a pound sign here. I used a star. I got that wrong. That's just a minor detail. Okay, so now we have it printing correctly. The next step is to get the default constructors to work. So we're going to fill this constructor out, student. And then we're going to test it to see if it matches their test file. So I'm going to sit here for a little bit. Again, the toString is going to print Dovey misses, so we print the last name, a comma space, the first name, and a new line. The toString then adds to this return string GPA colon and the GPA and a new line. Then grade level colon, the grade level, ID pound sign, the ID level, and a new line. We return this toString. The return string comes out of toString here. That is going to go into the driver here, where println calls it. Println needs a string. And all objects in Java have the toString function. Comes out here. If we don't have a toString, let's come out the toString and see what happens. Control backslash comments and uncomments. So if we don't have a toString, it will still run, but now we get the default toString, which prints the hash of the object number. So every object in Java will print with a toString, but it doesn't make sense until you overload that with a toString. So that is what we've done here in the student. We've overloaded the toString by making our own toString. I'm going to do control backslash, this uncomments it, now we're back to normal. The next thing, or the last thing we need to do, is to create a default constructor. And we can do that anywhere. Let's do this at the bottom. Default constructor looks exactly like this, open and close parentheses. We want the student to be able to run this. We do public. It sets the two names to none. They already are none, so we don't have to do anything. It sets the GPA to 0. It's already 0 up here. And I'm sorry, 0.0 sets the grade level to 0. These are all automatically set. We don't have to change them, so all we need in the public student is nothing. We have nothing the public student should run properly. Let's go back to our test driver, remove the comments from those using the default constructor. So let's look and see what we just did. We made a new public student default constructor with nothing in it. And we uncommented the using how we testing that default constructor. So let's run this. We're going to look at the output and compare it to the output that I have. I missed something. Can someone tell me what I missed? It doesn't look right. The ID is not incrementing. So I need to go back to my student, find that default constructor I just made, and increment the ID. Now if we run it again, I have one thing, they now increment. Yay, looks good. Looks the same. Maybe it's fixed, except I have these spaces. Right, I don't need these spaces. In the output, there's no spaces. Here I have spaces. So the very last new line I'm going to remove from my printer. The very last new line I need to remove from the printer. Now I run it again. I think I'm done, right? Yay, I'm done, right? So now we take this and we stick it in an adhesive, it's going to break on us and say, you're not done. Let's look at adhesive. Hello. Here we go. I need to stick it right in here. So I'm going to copy my student. I'm going to copy everything. Control A selects everything. Control C copies it. Go over here to the adhesive. Control V pastes it all. And when I run it, it's going to say it's not working right. Ready? Maybe I'm lucky because there's a lot of errors in this, and Adhesive's test driver better pick them up. And it picked up 10 of, this is enough to pass. Look at this. It's completely broken, and it's enough to pass Adhesive. So let's look at what's broken. So I need to go through what's broken, because Adhesive does not do it for you. Let's look at what it must do. Where's the description? It's up here somewhere. Here we go. Right here above my default constructor, or my parameterized constructor, I'm going to do the start of the comments again, slash star star starts comments for this section. And into these comments, I'm going to paste what I want it to do. So I'm going to copy all this stuff here. Control copy. I'm going to paste it right here on this line. Control V. And I'm going to go through and fit it into my little window here. This tells me what I need to do. I'm going to make this window a little bigger. And we're going to test this with a better black box tester than what we got in Adhesive. I think there's something here. There is. Is that it? That's it. Okay, let's look at this. The grade level should only be allowed to range between 0 and 12 inclusive. Let's go test that. Here, the grade level is 7. How about 77? I've been in school forever. Right? I've never left school. I'm in 77th grade. Let's run this and see what happens. I'm now in the 77th grade. This should not be. Should only be allowed to be ranged between 0 and 12. Otherwise, set it to 0. So I need to fix this. It's not 0. Go to Student Java. Right here, I set the grade level. If grade level is greater than 12, grade level equals 0. Let's run it again. I'm still 77, 0. It's fixed. Okay, one's fixed. Well, out the other way, make it smaller. So we test making it smaller. Now I'm in the negative 77th grade. I run it. Uh-oh, they let me get into the negative 77th grade. Let's fix it. So if I'm greater than 12, or my grade level is less than 0, then we set it to 0. So now we've set it to the right range. We need to do the same thing with the GPA. GPA should only be between 0.0 and 4.5 inclusive. So here the user sets the GPA. If GPA is less than 0.0 or GPA is greater than 4.5, then we set GPA to be 0.0. Let's test this. Maybe I broke it. Maybe that's not what I need to do. All right, so where am I? I'm here. We're testing grade level. More than 4.5. I just got 1,000. And I got an AAA+++, like the credit rating in the US. Let's run this, see what I get. GPA is 0. Okay, good. All right. I have negative 1,000, like the credit rating of Venezuela. No, Colombia. Colombia, there we go. I have the credit rating of Colombia, negative 0, 0. Or better yet, Mogadishu. That's off, or not Mogadishu, what's that called? The country that's in civil war for like ever. No, no, no. That's where we went and we like tried to do the aid Black Hawk Down. No, it's not Syria. You don't remember? Okay. No, it's one of those Horn of Africa countries. The Italians conquered it for a little while, and then it got their independence from Italy. Ethiopia every now and then comes and helps them. I forget the name of the country. But it's a mess. You don't want to go there. They have pirates all the time. Somalia. There we go. Somalia. Somalia's in trouble. Yemen's in trouble. South Yemen. Yeah, you don't want to go there. All right, so now it's working. Turn off the noise, please. How much time do I have left? Okay, we're doing fine. Okay, so now we have these things. Now I'm going to show you that we have another error that does not show here. Let's put this into Edhesive and see what happens. So I can put my new student in Edhesive. Control A, copy. We stick it in Adhesive, right? We can do this again. Here we go. Control A, Control V. We paste over. We have our checks in here now. All right, let's make sure our checks are in there. Yes, we run this and see if Adhesive is completely happy with us. Pass, pass, pass. Okay, now there's another error that Adhesive has missed. So we're passing Adhesive. Perfect. Yay, we're great, right? Yeah, no. There's an error. Sorry, what?
How is it that there's still an error even though we're pressed hold?
I'll show you. Are you ready? Okay, the way we are using ID. We have an ID that we've made static. And a static variable is owned by the class, by the blueprint for the class, not by the individual class members. So all the individual class members share the ID. Are you ready? All we need to do to show that this is an error is go to our test driver and print student 1 again. Control copy, print it after we printed student 4. And we do not need to make student 1 again. All we have to do is print them. Run this. Should student 1's ID change? Is student 1's ID changing? Student 1's at the top. What's student 1's ID now? What's it supposed to be? What happened? Incremented it. So all the students share the same ID.
Yes.
Do you want that? No. We need to give the students an individual ID each. Now, Adhesive missed this, right? They missed it, which means Adhesive has an incomplete black box test. We are going to make a complete black box test. Student 1 should have ID 1. It does not. We need to fix this. Not only does everybody have an ID, let's call this one the next ID. And now we need to change next ID, but the student itself needs an ID. Private, not static, int ID. Now all the students have an ID. We have to set those IDs. We're going to start next ID to be 0. Now, instead of ID plus plus, this ID equals plus plus next ID. If I got it right. Did I spell it right? It's mad at me. Next ID. Oh, capital ID. Let's see. Is it capital N next? It is capital. I need to make this lowercase. Sorry. There we go. And same thing here. Where's the other printer? Here it is. ID equals plus plus next ID. Now if we run this, all our students have their own ID. Look, I print student 1 up here, and I print it down here, and the ID is the same. And that happens because this is each individual student ID. It's not static. ID is each individual student, and next ID is the next one to do. So we're remembering next ID. The class blueprint remembers next ID. Each individual student doesn't care what it is after it uses it. Each individual student remembers their own ID. And this will tell you what this keyword static does. Keyword static makes the variable that you make static belong to the class blueprint and is shared by all the instances of the class. So next ID is shared by all the different students you make. Each individual student that you make has its own ID. Each individual student that you make has its own GPA because it's not static. Each individual student that you make has its own grade level. Each individual student that you make has its own last name. Each individual student that you make has its own first name. So you see, you can pass adhesives tests by simply making the default constructor and not testing for validity, right? We did not put these in, and we got 10 out of 12. We test for validity, and adhesive says you're perfect, and you're not. When you make your own black box tests, and this is the important part, you need to test every public, you have to test the public interface. The public interface is every public method and every public variable of your class. How many public variables do we have? How many public variables do we have? 0. They're all private. That means you cannot set them. Let's try to set them, right? Uh-oh, I got the ID wrong for S1. Let's fix it. S1.id equals 55. It won't let me because ID is private. If we make ID public, I save all so it sees the new one. Now it lets me. So the user can use all public things in any function of any other class that can reference your class. But the user cannot use private things. So we want ID to be private so the user doesn't set the ID to something new. We want to make the next ID private so the user doesn't set the next ID to something we've already used. Here we're protecting grade level and GPA. We want to make them private. Do we need to protect first name or last name? Is there any validation on first name or last name? We can make those public. This will allow the user to change, oopsie, not grade level. Go away, grade level. That's still private. And then the user can change these directly. Once you make the student, should we be able to change the student's name?
Yeah.
You say yes? Then make it public. Yeah. Right, student names change, so you should be able to change a student. GPA changes, you should be able to change GPA and so on. But GPA is protected. And then some point we're going to learn about setters and getters. Have you learned about that yet? No. Okay, so we're going to do that. So this concludes Lessons 5 programming exercises. We've talked again about the concept of a student or a class, an object, An object contains the variables and the methods that you need when you're using that object in a program. Turn off the noise, please. The toString method, to summarize, is used by every Java class. Even if you don't make a toString, it has one, because every Java class inherits from the Java object. Every class inherits from, I think it's java.object, but I'm not sure. But we're looking for object. And every object has a toString. There are other things that objects have. If you want to, Google Java objects, you find that. So we've made a Java object. We've made a test driver. We see that the job of a test driver tests the public interface of the class. And the public interface is the set of all public members of the class. And that's it for today. Any comments, questions, concerns? All righty, I'm going to save this and upload it. 36 minutes. These things go a little